Hi everyone. In this video, first topic we are going to discuss is centroid of a triangle. Before defining centroid, we must understand the concept median of a triangle. So, what is the median of a triangle? A median of a triangle is a line segment joining a vertex to the midpoint of the opposite side, thus bisecting that side. So here, this is the vertex and this is the opposite side of the vertex and this is the midpoint of the opposite side. So, median is the line segment that joins vertex to the midpoint of the opposite side. This line is called the median. Since this is the midpoint of this opposite side, this line divides this opposite side into two equal parts. Now consider this figure. Since the triangle ABC has three vertices, we get three medians. Consider this vertex A. BC is the opposite side and E is the midpoint of BC. So AE will be our first median. Similarly, if we consider the vertex B, AC is the opposite side and F is the midpoint of AC. Therefore, BF is a median. And similarly for C, since D is the midpoint of AB, CD is a median. So we got three medians and these medians are drawn in the using the blue color. Okay. Now since D is the midpoint, this line, that is CD, divides AB into two equal parts. Both these parts will be equal, that is AD and BD will be equal. Since E is the midpoint, AE divides the BC into two equal parts, that is BE and EC will be equal. And similarly, since F is the midpoint of AC, BF divides AF AC into two equal parts, that is AF and CF will be equal. Now, altitude and median are two different things. That is, if I consider a triangle like this, one second. This is our triangle ABC. What will be the altitude of this triangle? One of the altitude of this triangle. If I consider the vertex A, then altitude is the perpendicular line that we draw from the vertex to the opposite side. So, when we draw a perpendicular, it will be like this. Let this point be E and this will be 90 degree. So, AE is a perpendicular line that we draw from the vertex A to BC. So, the altitude AE is an altitude. So, altitude means a perpendicular line that we draw from the vertex to the opposite side. Is one of the altitude. Similarly, we can draw altitudes from the vertex C and B also. Now, what will be the median? Will AE be a median of this triangle ABC? No. AE will not be a median because E is not the midpoint of BC. If I am considering the midpoint here, let it be F. So F is the midpoint of BC and if I draw a line from A to F, then this AF is the median of BC. Here F is the midpoint of BC. So AF is the median of triangle ABC. And A is the altitude and AF will be the median of the triangle ABC. So don't confuse median and altitude. Now we are going to define the centroid of the triangle. Centroid of a triangle is the point of intersection of medians of a triangle. Here AB, BF, CD are medians, right? These are the three medians. So centroid of a triangle is the point of intersection of these medians. So what is the point of intersection of these medians? In the figure, this point. This point is the point of intersection of these three medians. So this is our centroid. This is our centroid. So I am naming this point as some G. So G is the centroid of the triangle ABC. Now, if the three vertices A, B and C are given, how can we find the centroid of the triangle? Let A be the point x1, y1 and B be the point x2, y2 and C be the point x3, y3. Then how can we find the centroid of the triangle ABC? The coordinates of centroid of the triangle ABC are given by x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. This is the formula to find the coordinates of the centroid. So remember this formula and also the definition of the centroid. Centroid means the point of intersection of medians of a triangle, and this will be the formula to find the centroid of the triangle. Our next topic is incenter of a triangle. Incenter of a triangle is the point of intersection of internal angle bisectors of the triangle. That is, internal angles means here consider this triangle ABC. Here this is an internal angle, this is an internal angle, and this is also an internal angle. And angle bisector of a triangle means consider the vertex A and the angle here. AD is a line that divides this angle into two equal parts, then that line is called the angle bisector. That is, angle bisector divides the angle into two equal parts. Here, one second. Here, this angle and this angle are equal. AD divides angle A into two equal parts. Then AD is called the angle bisector of this triangle ABC. Similarly, BE divides the angle B into two equal parts and CF divides the angle C into two equal parts. So, AD, BE and CF are the angle bisectors of this triangle ABC, and their point of intersection is called the incenter of the triangle. Here, their point of intersection is denoted by, this is the point of intersection of the angle bisector and it is denoted by I. Therefore, I is the incenter of this triangle. We can also define incenter of the triangle in another way. That is, it is also a center of circle touching all sides of the triangle. I have shown this in the second figure. Here, consider this figure. Here, this is the circle that touches all sides of this triangle. And the center of this circle is called the incenter. That is, the point of intersection of the angle bisectors of the triangle and the center of the circle that touches all sides of the triangle will be the same point, and that point is called the incenter of the triangle. Now, The incircle of a triangle is the largest circle that fits in the triangle. That is, this circle is also called the incircle of the triangle and its center is the incenter. Also note that its center is the one point in the triangle that is equidistant from all sides of the triangle. Since this is a circle, these three are radius of the circle. So, the length of these three lines will be the same, and this is the sides of the triangle. I am naming it as one second. I am naming it as A, B and C. So here AB is a side and this red line is the distance from AB to the center, that is the incenter, and also AC is another side and this is the distance from AC to the incenter, and similarly in the case of BC also. So this is the one point in the triangle ABC that is equidistant from all three sides of the triangle ABC, because these are radius of the circle and they will be the same. Now, if the three vertices of the triangle ABC are given, how can we find the incenter of the triangle? Let A be the point x1, y1, B be the point x2, y2 and C be the point x3, y3. Then what will be the incenter of the triangle? The coordinates of incenter of triangle ABC are given by ax1 plus bx2 plus cx3 by a plus b plus c, comma ay1 plus by2 plus cy3 by a plus b plus c. Here A, B, C are sides of triangle ABC. That is, here let this side be our small letter A and this side be our small letter B and this side be our small letter C. So, if we know the vertices of the triangle ABC, we can easily find the sides of the triangle using the distance formula. That is, if two points are given, then the distance between them can be found using the distance formula, and AB will be the length of the side of the triangle ABC. So, if A and B are given, then AB can be found using the distance formula. So, similarly, we can find the other sides also using the distance formula, and then we can apply this formula to find the incenter of the triangle. Circumcenter of a triangle. The circumcenter of a triangle is the point of intersection of the perpendicular bisectors of the sides of the triangle. What is meant by the perpendicular bisector of the sides? The perpendicular bisector of the sides is the line segment that divides the sides into two equal parts, and also it bisects that side perpendicularly. The angle will be 90 degree and this line divides the side into two equal parts. Here the perpendicular bisector of AB is the line. This is the line. So this bisect AB perpendicularly, that is, it divides AB into two. It is a straight line that divides AB into two equal parts. Similarly, this straight line divides CB into two equal parts, and this is the angle 90 degree, and also similarly this line divides the side CA into two equal parts, and the angle here is 90 degree. These lines are the perpendicular bisectors of the sides of the triangle. and their point of intersection is called the circumcenter. We can also define the circumcenter in another way, that is, if we draw a circle that touches all three vertices of the triangle ABC, then its center is called the circumcenter. So, the point of intersection of the three perpendicular bisectors of the sides and the center of the center of this circle will be the same point, and that point is called the circumcenter of the triangle. Now, note that the perpendicular bisectors of the sides of the triangle may not necessarily pass through the vertices of the triangle. That is, consider this perpendicular bisector. This is the perpendicular bisector of the side AB, and this line doesn't pass through any of the vertices. It does not pass through C. So, perpendicular bisector of the sides of a triangle may pass through C, but in some cases it may not pass through the vertices of the triangle. So, the perpendicular bisectors of the sides of the triangle may not necessarily pass through the vertices of the triangle. Here, this perpendicular bisector also does not pass through the vertex B, and the perpendicular bisector of BC does not pass through the vertex A. So, in some cases it may pass, but in some other cases it may not pass through the vertices of the triangle. Now, consider the acute triangle, right angled triangle, and the obtuse angled triangle. What will be the circumcenter of these triangles? If we consider the acute triangle, the circumcenter will lies inside the triangle. But what about the right angled triangle? For the right angled triangle, the circumcenter will be the midpoint of the hypotenuse. This is the angle 90 degree. The side opposite to the angle 90 degree is called the hypotenuse. So the circumcenter will be the midpoint of the hypotenuse. And what about the obtuse angled triangle? For the obtuse angled triangle, the circumcenter will be outside the triangle. So the circumcenter of a triangle may be inside the triangle, or outside the triangle, or on the triangle. It depends on the type of the triangle we are considering. So remember these three figures, and also remember that for the right angled triangle, the circumcenter is the midpoint of the hypotenuse. So in all these three cases, the perpendicular bisector does not pass through the vertices of the triangle. So perpendicular bisector means the straight line that divides the side into two equal parts, and the angle here will be 90 degrees. So this is the perpendicular bisector of the side CD. Now, if three vertices of the triangle ABC are given, how can we find the circumcenter of the triangle? Consider triangle A, B, C. Let A be the point x1, y1, and B be the point x2, y2, and C be the point x3, y3. Then what is the circumcenter of the triangle? The coordinates of circumcenter of triangle ABC are given by x1 sin 2a plus x2 sin 2b plus x3 sin 2c by sin 2a plus sin 2b plus sin 2c, y1 sin 2a plus y2 sin 2b plus y3 sin 2c by sin 2a plus sin 2b plus sin 2c. Here, capital A, B and C denote the angle of the triangle. So if we know the angle of the triangle and the three vertices, we can easily find the coordinates of the circumcenter of the triangle ABC. Now our next topic is orthocenter of a triangle. The orthocenter of a triangle is the point of intersection of altitudes. We already discussed what is an altitude. Altitude is the perpendicular line that we draw from a vertex to the opposite side. So consider the vertex C, and here CP is a perpendicular line that we draw from C to the opposite side AB. Here P may not be the midpoint of the side AB. So this straight line that we draw from a vertex to the opposite side, here the angle will be 90°. It is a perpendicular line. This line is called the altitude. So here CP is an altitude. Similarly, AN is an altitude and BM is an altitude to the side CA. So the point of intersection of these altitudes is the orthocenter. So the point here is the orthocenter of the triangle. I have given here the definition of altitude. Altitudes are the lines through the vertices and perpendicular to the opposite side. Now, what will be the orthocenter of an obtuse angled triangle? That is, consider the triangle. Sorry. This angle will be more than 90 degrees. So this is an obtuse angled triangle. So here ACB is an obtuse angled triangle. Obtuse angled triangle. So how can we draw the altitudes here? Here I told you altitudes are the lines through the vertices and perpendicular to the opposite side. So I am considering the vertex A here, and the opposite side of the vertex is BC. BC is the opposite side of the vertex. So here A is the vertex I am considering and its opposite side is BC. So I have to draw a perpendicular line from A to BC. We cannot draw the line like this. It is not perpendicular. Here the angle is not 90 degree. So we cannot draw a perpendicular line from A to its opposite side like this. So how can we draw a perpendicular line from A to the opposite side? I am extending this side BC here. Now draw a perpendicular line from A to this line. A second. So this is our altitude from the vertex A to BC. Here the angle is 90 degree. Now consider the vertex C. The opposite side of C is AB. This is the opposite side of C. AB is the opposite side. So we can easily draw a perpendicular line here. Here the angle will be 90 degree. Now I am extending this line, because this is one altitude. We have to find the point of intersection of altitude, right? One second. Let me, so there is a, this is not a, let me redraw that line again. This is our, one second, this is our vertex C. So I have to draw a straight line. This will be our angle 90 degree. So this is the altitude from C to the opposite side AB. Now consider the vertex B. We have to draw an altitude from B to CA. The opposite side of B is CA. So if we draw a line from here like this, it may not be 90 degree. So we cannot draw it like that. So how can we draw? So I am extending, the opposite side of B is CA. So I am extending this line here. Now I am drawing a perpendicular line from B to that extended, sorry, from B to that extended line. So here the point of intersection is this. Here the point of intersection is this. So this will be the orthocenter of the triangle. So for the obtuse triangle, the orthocenter lies outside the triangle. Now what about the orthocenter of a right angled triangle? Consider this right angled triangle. Here the angle is 90 degree. So I am naming this triangle as, one second, I am naming this triangle as A, B and C. Here if I consider this line here, that is if I consider BC, then we have to find the altitude of BC. Here if I consider the vertex A, the opposite side of the vertex A is BC, and we know that the altitude is the perpendicular line from A to the side BC. So here if I consider A, the perpendicular line from A to BC is AB, right? So this is the altitude from A to BC. Now if I consider B, the opposite side is AC. So altitude from B is the perpendicular line from B to the side AC, which is the perpendicular line will be BC itself. So this is the altitude from B to the opposite side AC. Now if I consider the vertex C, the opposite side of C is AB and the perpendicular line from C to AB is the line PC. So these lines are the altitudes of the right angled triangle ABC and their point of intersection is at B. So for a right angled triangle, the orthocenter will be the vertex at which the angle is 90 degree. So here B is the angle, B has the angle 90 degree. So orthocenter is the point B. For the right angle triangle, orthocenter will be the vertex at which the angle is 90 degree. If three vertices of the triangle ABC are given, then how can we find the orthocenter of the triangle? Consider triangle ABC. Let A be the point x1, y1 B be the point x2, y2 and C be the point x3, y3. Then the orthocenter of the triangle are given by the coordinates of orthocenter of triangle ABC are given by its first coordinate will be x1 tan A plus x2 tan B plus x3 tan C by tan A plus tan B plus tan C. y1 tan A plus y2 tan B plus y3 tan C by tan A plus tan B plus tan C. Here here capital A, capital B and capital C are angles of the triangle ABC. So if we know the vertices and the angles, we can easily find the orthocenter of the triangle ABC. I hope you all understood the topics that we discussed in this video. In the next video, we will discuss the problems related to these topics. So if you liked this video, please subscribe my channel and click the bell button for the notifications. Thank you.